Combustion means burning the alkenes in oxygen. There are two main kinds, complete combustion and incomplete combustion. It depends on whether we have sufficient oxygen. When there is sufficient oxygen, the alkenes will burn and we will get carbon dioxide and water as the only products. Again, this is similar to, or this is the same as alkanes. Right? Remember that these are just hydrocarbons. So for example, if we have propene, C3H6, burning with oxygen, under complete combustion, where there is sufficient oxygen, we will get CO2 and water as the only products. The carbon will completely oxidize to CO2. The hydrogen will completely oxidize to H2O. So if you are required to do a balance equation, we will just write out O2, CO2 and H2O and balance accordingly. There are 3 carbons to balance. Balance the hydrogen, 6. We multiply H2O by 3 and then we balance the oxygen. 6 plus 3, we have a total of 9 oxygen. 3 times 2 plus 3. So to make this 9, we will need to have 9 over 2. If you're uncomfortable about leaving them in fractions, once you get this 9 over 2, you multiply the equation throughout by 2. So this becomes 9, 2, 6, 6. So this is for complete combustion. Incomplete combustion is when we do not have enough oxygen. The carbon will form soot, the black smoke, or the carbon will form carbon monoxide, poisonous gas. The hydrogen will still form water. Again, you will not be required to write out balance equations for incomplete combustion if you do not have information on the ratio of carbon forming to carbon monoxide. So just focus on complete combustion, the writing of equations. Having said that, it is not likely we will use alkenes for burning of fuels, right? Because they do not burn as well as alkanes. Addition reaction, when we have 2 or more than 2 molecules combined, giving us just one single molecule in the end, these are known as addition reaction. So in general, the alkene reactions, it takes place at the functional group, the double bond, and then we will end up with one single molecule. So the double bonds become single bonds. We can also say that the unsaturated hydrocarbons become saturated because we get rid of the double bond and we end up with single bonds. First example of addition of alkenes is hydrogenation. By the name, it indicates that we are adding hydrogen to the molecule. Be familiar with the conditions, right? In your syllabus, we require 200 degrees Celsius and the catalyst used will be nickel. For example, if we have ethene, 2 carbon alkene, and then we add hydrogen gas, H2, single bond also. What happens is one of these hydrogen will be attached to one carbon. The other hydrogen, the other part, will be attached to the neighboring carbon. So we end up with a molecule that looks like this. So you should recognize that this is an alkane, this is an ethane molecule. So we can convert alkenes to alkanes by hydrogenation under these conditions, 200 degrees, nickel catalyst. And of course you have to add hydrogen as a reactant. Bromination means the adding of bromine. We can use a solution of bromine, or sometimes called aqueous bromine. What happens is the bromine solution, which is originally brown color, it will decolorize when alkene is present. One way we can write the structure just like before, Br2 single bonds, one bromine will be attached to the one carbon, the other bromine will be attached to the next carbon, giving us a molecule that looks like this. There are other possible products formed, but this is a product that you have to be aware of within the O-level syllabus. This is known as 1,2-dibromoethane. So the brown color of the solution is due to the Br2 molecules. Once that's broken up and used up, we will have a colorless solution or colorless mixture. So one way we can use it in a lab to test, maybe we have two test tubes of unknown solutions. One is alkane and one is alkene. And then we add bromine solution, which is brown, to both test tubes. Okay, we do give it a shake. The alkane will remain or will end up as a brown mixture because the bromines remain unreacted. Whereas for the alkenes, the bromine breaks up to add to the double bonds, and then it will be decolorized. So this is a very important test for unsaturation. Unsaturated molecules will decolorize bromine solution, whereas bromine solution will remain brown when added to saturated molecules.